Counts and proportions are two very commonly used summary statistics for categorical data. Let's again take the example of passenger data. However, this time we will focus on the gender of each passenger instead of their ages. Well, gender is a categorical feature. So in our list, we have either male passengers or female passengers. So the total count is 10 as we have 10 gender values. And as we have either male or female as gender values, therefore the unique count is 2. So for such categorical data, we are also interested in category-wise breakup. So let's take the count breakup. So we have 4 male passengers and 6 female passengers here. But sometimes you are more interested in the proportions instead of the actual count. So to get the proportion, we can simply divide each category count by the total number of passengers. So for males, the proportion would be 0.4, means there are 40% male passengers in the whole list, while we have 60% female passengers. So straight away, we have gained some insights about the data, that is, we have more female passengers on the list than the male passengers. So let's see how we can come up with such summary statistics using pandas in the next clip. In this clip, we will use pandas and numpy to get summary statistics for categorical features. So here we are again in the Jupyter Notebook. Well, we have already seen the usage of describe function to get summary statistics for numerical features. But you can use the describe function on categorical features as well. All you have to do is to set the include parameter of the describe function to all, and you are done. Let's execute the cell. And as you can see, we have some information for categorical features as well. So we have total count and unique count. Like for the embarked column, there are 3 unique points where people got into the Titanic ship, and the point from which most people embarked was S, shorthand for Southampton. Well, in this output, we don't have category-wise counts or proportions. So for that, you can use another useful function, that is value counts. Here we are using the value counts on the gender or sex attribute. Let's execute this cell. And as we can see, we have 843 males and 466 females. If you want to have category-wise proportion instead of counts, then you can set the normalize property to true in the value underscore counts function. Let's execute this cell. So here we have the proportion with us. So roughly 64% of passengers are male and rest 36% are female. So as you can see, value count function is a very handy function. Now let's apply this function on other columns. In the next cell, we are applying the value count function on the survived column. Well, even though we have encoded the survived column as integer, but actually it is a categorical feature, means a passenger is either survived or not survived. So here we are extracting all those passengers for which the survived value is not -888. So if you recall, we have set this default value for survived attribute of test data for which we don't have information of survival. So basically we are extracting the training data set only from the data frame, and then we are trying to find how many passengers survived in that training data set. So let's execute the cell. And as we can see, 342 passengers survived, means for 342 passengers, the value of survived attribute is 1. Now let's apply the same on the passenger class to see how many passengers were there in each passenger class. And here we have the breakup. And as we can see, most of the passengers were in third class. Other than in numbers, you can also visualize the counts or proportion. So on the output of the value underscore counts, we can apply the plot function. And here we have set the plot type as bar because we want to make a bar plot. Let's execute this cell. And here we have a very nice bar plot where each bar represents the count of passengers in the corresponding passenger class. However, there are certain issues with this plot. Well, if you can see, the labels on the x-axis are not rendered properly. Also, it would be good if we can have some title of the plot. Also, you may not like the color of the bars. At least I don't. Not only this, you might have noticed some matplotlib output here, which is a bit distracting. So let's try to tweak this plot using various parameters of the plot function. So in the next cell, we have set the rod property to 0, so that the x-axis labels become horizontal. Then we have set the title of the plot using the title attribute. And if you want to set the color of the bar, you can use the color property. Here we have set it to C, which is a shortcut notation for cyan color. Also, to suppress the matplotlib output, we can use a semicolon at the end. So now let's execute the cell. And here we have our desired output, a much better looking plot.